Let's start the new session. As usual, good afternoon. So welcome to my channel, IPS Videos. The previous session, just we take a brief overview about the chapter metals and non-metals. Then let's understand what is or what are metals, what are non-metals, which materials are we are using. We are using many materials in our day-to-day life, right? So some are made from metals, some are made from non-metals. So whatever metals or non-metals are playing a very important role in our day-to-day life, right? So let's start. What are metals and what are non-metals? Okay. So there are 118 elements are there. So in that 118 elements mainly classified into two categories. One is metals and another one is non-metals. And in this, some elements having intermediate properties like metals and between the metals and non-metals, they are called as metalloids. They are called as metalloids. So these metalloids are having intermediate properties of metals and non-metals. So boron, silicon, germanium, beryllium, antimony, arsenic, polonium are the examples for are the 7 recognized metalloids. So whenever we see the periodic table, so in a P block element, second block elements. So whenever it is so if it is just model of in a periodic table, we are able to see a step. So whenever you see the periodic table, we observe a different like step like. So you need to do steps like shape you are able to observe. So boron, silicon, germanium, arsenic, like that. So we have a stepwise manner, a zigzag. So see that. So 1 minute, so I will give a clarity. Just wait. So I will show you the picture of the modern periodic table. So this is the modern periodic table. Right. In the modern periodic table, you are able to see a stepwise arrangement of molecules. So here boron, silicon, arsenic, tellurium, then astatine are the examples for metalloids. Their properties are intermediate. Their properties are intermediate to metals and non-metals. So this is the modern periodic table. Right? Whenever you search in internet or when you observe the picture, then you are able to understand that the modern periodic table. So the 13th A, 14th A, 15th A, 16th A groups are there. So in that boron, you observe that with a black thick line is given in the periodic table. So that elements are nothing but metalloids. So thank you for your patience. Thank you. Maybe you are understood. So little bit disturbance happened. Okay, no problem. So it is helpful to you only. So and sorry for little inconvenience for that. So for giving idea what about metalloids. So their properties are intermediate between the metals and non-metals. Then what are metals? What are the metals? So metals are the elements which form positively charged ions by using electrons. Example: sodium, gold, iron, copper, silver, aluminum, zinc, potassium, lithium, lead, platinum. These are all the examples for metals. Then non-metals. Non-metals are the elements which form negatively charged ions by gaining electrons. So examples are chlorine, oxygen, fluorine, iodine. So these are some examples for non-metals, right? So then, so what are metals? What are non-metals and what are the metalloids? So while discussing about the elements are classified mainly into one is metals and another one is the non-metals. The other category is metalloids. Let's discuss the physical properties. Physical properties of metals and non-metals. Instead of discussing separately physical properties of metals, physical properties of non-metals, so directly by comparing the physical properties of metals and non-metals, so we understand that the different physical properties of metals and non-metals. So let's discuss the properties, the physical properties of metals and non-metals. State in the sense in which form they are available. Form of availability. So in which form they are available. So metals are generally solid. Metals are available in the nature in the form of solid. Then here one exception is there. Solids. One exception is there. Mercury. Mercury is a metal, but it is a liquid metal. The exception. So mostly non-metals are gaseous state. Mostly non-metals are gaseous state except bromine. Bromine is a non-metal which is available in the form of liquid. Hardness and strength. So they are strong enough for strong or not. So generally metals are strong. Metals are strong in nature. They have more strength and hardness. Whereas the non-metals are brittle. So they are, instead of using the word soft, they are brittle in nature. So when we beat the metals, so they won't break easily. Whereas when we beat the non-metals, so they can break easily. So brittle in nature. But hardness and strength, except the sodium and potassium, both are the metals, but they are soft. In nature. Whereas coming to non-metals, diamond is a non-brittle in nature. It is a strong one. So diamond is a non-metal. It is the strongest material in the world. Density. So generally density means mass per unit value. Mass by value. Mass per called as density. So mass by value. Mass by value, but also indicated heavier. They have heaviness or mass. So indirectly they are telling about the weight for our understanding. Maybe heaviness or not. Heavier substances are low light substances. Light in weight or more in weight. So mass by value, more density. So then metals are generally denser, whereas these are less. So in physical properties, metals are higher density. Metals having high density. So metals have high densities except sodium and potassium. So by saying that metals are high density, you can say that metals are heavy substances. For example, the density of iron is 7.8 gram by centimeter cube. So whatever, then the values are we learn later. Just understand that what is. So denser, then they are the less denser. So these are the heavier substances, they are the lighter substances. Then coming to the melting point and the boiling point. Melting point means at which temperature they melt. So they convert. Melting point means the temperature at which it turns into liquid. So the temperature at which they melt and turns into vapor. Melting point, the temperature at which the solid melts into liquid. Boiling point is the temperature at which they turns into gases. So generally metals having high boiling points and more melting points, whereas the non-metals having low boiling point and melting point. So there is some exemptions are there for every property. So let me discuss. So melting point of metals is more, then whereas the melting point of non-metals is less. Metals have high melting points and boiling points. So for example, iron metal has a high melting point. Iron melting point is 1535 degrees centigrade. Iron melt at 1535 degrees centigrade. Whereas the copper 1083 at 1083 degrees centigrade. Then copper melts into liquid. Right? Then malleability means drawing into thin sheets. So when we hammer, so if you take a piece of iron or iron nail, so when we strike on the iron nail by using hammer, so because of hammering, so it turns into flat surface. It forms a flat surface. So malleability. So by hammering the metals are going into thin sheets. So the thin sheets we can call as foils. So metals are malleable. Whereas the non-metals are non-malleable. So we can make them into thin sheets. So metals are the ability to make them into sheets. by gritting or by hammering. So the property or the ability of a substances or the materials, whether metals or non-metals, which can be joined into thin sheets, are called as malleability. So generally metals are malleable, then non-metals are non-malleable. So metals are malleable. Metals are malleable. Metals are malleable. So malleability is an important characteristic property of solids. Most of the metals are malleable. So gold and silver are some of the best malleable metals. Similarly, aluminium, copper, silver are also hammered and they turns into sheets. So aluminum foils. Aluminum foils are used for packing food items like biscuits, chocolates, medicines, cigarettes, etc. So these are all the uses of metals and non-metals we will discuss later. So I hope you understood. Malleability is the property or the ability of a material or a substance drawing into thin sheets by hammering. So mostly metals are malleable, then non-metals are non-malleable. Then coming to ductility. Ductility means drawing into or making into fine wires. The property of a substance and the property of a material which can be making or which can be drawing into fine wires. So the property or the characteristic property of material which can draw into fine wires. We can call as ductility. So metals are ductile. Whereas the non-metals are non-ductile. So we cannot draw into wires. So ductility is one of the property. Then sonority. Sonority means making sound. Making ringing sound or deep and clear sound. The ability of the matter or the ability of the material which can produce ringing sound. So when we drop a metal plate on the hard surface, it produces sound. Then schools and colleges have bells made of metals. So because of metals are having the property, we call it sonority. So metals are sonorous. Whereas the non-metals are non-sonorous. So those materials which are in malleabilities are malleable substances. The materials or the substances can be drawn into sheets are called as malleable substances. Whereas the ability or the materials which are able to draw into fine wires are called ductile materials. Are ductile substances. So those materials are able to produce ringing sound are called as sonorous materials. Right? Then coming to luster. So luster means the shining surface. shining property. So luster means the property of the surface. So luster or lustre. So having shiny surface. Having shiny surface. Luster or lustre means the surface of the material, either metal or non-copper, shiny in appearance. Shiny in appearance. So why shiny in appearance? The light is falls on the surface of the material. If the light is reflects and surface appears as bright and having some shiny surface. So observe that the body cap has shiny surface because it is made up of metal. So their cooking utensils, cooking have shiny surface. Then newly purchased vehicle rims are to shiny surface, right? Because of they have shiny property. So the shining property of a material in science you can call as luster. So luster or lustre means having shiny surface or having shiny property. So metals are luster, whereas the non-metals are non-luster. So the substances which have shiny surface you can call as lustrous materials. Okay, small disturbance outside. Luster is the property of the material having shiny surface. So metals having shiny surface are there. So they are luster. They have the property luster. So whereas the non-metals are non-lustrous. So lustrous materials. So those materials having shiny surface are called as lustrous materials. So heat and electric conductivity. So allowing the passage of electricity and heat is called as heat conductivity and electric conductivity. The property of a material which allows the electricity to pass through them is called as electric conductivity. So whereas the property of a material which allows heat to pass through them is called as heat conductivity. So those materials which are allow the electricity and heat, you can say that good conductors. Whereas these are the poor conductors. So those materials are those substances are allow the electricity is called as good conductors of electricity. Those did not allow the electricity is called as poor conductors or bad conductors or insulators. Then similarly heat conductor. So metals are the good conductors of heat and electricity, whereas the non-metals are the poor conductors of heat and electricity. Then due to this property, electrical appliances, cooking utensils are made by metals because of they are allow the heat and electricity. So because of they have the property of heat and electric conductivity. Then coming to hardness and strength. Hardness and strength. Metals are hard in nature. Metals are hard in nature. But mercury is liquid one, and potassium and sodium. Sodium and potassium are the soft metals. Sodium and potassium are the soft metals. Then we are able to cut with our with the knife, but we cannot cut the aluminium, iron with the knife. Then density. So in coming to the density, so luster, density. So physical state, as we know, mercury is a metal, which is a. Then density. We have studied that metals have high densities, but alkali metals such as lithium, sodium and potassium, such as sodium, potassium, lithium are the low density, having low densities. Then hardness and softness. Hardness and softness. Generally metals are hard in nature, when non-metals are soft in nature. But coming to the metals, sodium, potassium are the soft metals. But in case of non-metals are generally not strong. But diamond, which is a non-metal, the strongest material. This is the one exemption. Then coming to melting point and boiling points. Generally metals having high melting point, but this gallium is one of the metal which has low melting point. Similarly, sodium, potassium, cesium and gallium. So I am having this. Some exceptions in the physical properties. Exceptions. Exceptions in physical properties. State. Generally metals are solid in state, but whereas the mercury is a liquid. Mercury is a liquid, which is a metal. Then non-metals. Non-metals are, most of the non-metals are gases. Most of the non-metals are gaseous state. For example, bromine. The remaining are in the gaseous state. Carbon is solid state. Carbon is a solid state. So carbon, sulfur, phosphorus are the non-metals which are solid form. So bromine is a liquid state. So bromine is a non-metal. Bromine is a non-metal which is liquid state. Whereas oxygen, hydrogen, nitrogen are gases. Then carbon, phosphorus, sulfur are solid state. Then hardness and strength. Hardness and strength. So metals are strong in nature, but potassium and sodium are soft. Whereas generally we consider metals are hard in nature, but diamond, which is a non-metal, the strongest material in the world. Then density. So metals have having high density, except the potassium, sodium, right? Then generally non-metals are low density. Non-metals are the low density substances. Then coming to melting points and boiling point. generally metals having higher melting points and boiling points, except the potassium, sodium, lithium, gallium and gallium are having low melting points and boiling point. So gallium having very low melting point. So if we take gallium in our hand, now we place gallium in our palm, even at room temperature also, even below its room temperature, so it's melt into liquid. So this gallium is the properties of gallium is estimated by the great scientist Mendeleev. So Mendeleev classified the elements in different categories. So he assumed that he imagined that if in future if any metal, if any element is found, that element having low, so this is some history behind that. But so gallium, when we place gallium on our palm, so it melts. So gallium and cesium metals having low melting points of 30 degree centigrade, 30 degree and 28 degree respectively. The melting points of gallium and metals are slow as they start melting in hand. Because of they have very low melting points. Then coming to the malleability. So drawing into thin sheets, malleable, non-malleable generally. But when we consider wood, we are able to draw into sheet. Then plastics are also able to draw into sheets. Then ductile, sonority, luster. So luster having shiny surface. So generally metals having shiny surface we know. But iodine is a non-metal which has shiny surface. And diamond is a non-metal which also having shiny surface. Exemptions, all are the exemptions. Then heat conductivity and electric conductivity. So as we know, metals are the good conductors of heat and electricity. Whereas generally non-metals are the poor conductors of heat and electricity. In case of electrical conductivity, carbon is a good conductor. Carbon in the form of graphite. Graphite is one amorphous allotropic form of carbon. Carbon in the form of graphite is a good conductor of electricity. So we cannot classify the elements as metals or non-metals by the physical properties, because of maximally every physical property has exceptions. State, hardness, density, melting points, boiling point, sonority, luster, heat conductivity, electrical conductivity. Right? So whatever the physical property we have to find difference. So metals and non-metals. So each physical property has some exceptions. So we cannot classify the elements. As metals and non-metals based on the physical properties. So regarding to the physical properties and regarding to the chemical properties of metals and non-metals, no need to worry about the physical properties and the chemical properties, because the physical properties and chemical properties of metals and non-metals I have already learned class 8. So even maybe I expect that even you because they are very easy to understand. Then mainly which are highly malleable, which are highly ductile, which are having more sinus articles, which are having high density, low density, high melting point, low melting point. So maybe in this case the example, some of the elements or some of the example, maybe you have to remember that. But so the physical properties are very easy to understand. So don't bother much about the physical properties as well the chemical properties of metals or non-metals, because they are these properties are easily understood. So that's why I am also did not explain much according to the textbook. Then it take what are metals, non-metals, then metalloids, then physical properties. To explain, to give the introduction of the chapter, take 1 minute. Then physical property, to explain each and every property, maximum take so different types. Actually, we have to explain first the physical properties of metals. Then later we discuss the physical properties of non-metals. After that, then we have to compare the physical properties of metals and non-metals along with the exceptions. Right? So instead of taking the too much of time, whenever you form the table form, it is very easy to understand which are considered as the metals, which are not considered as the metals. So metals are the elements which are forms positively charged ions. Now, after the discussion of physical property, you can say that. So metals are the elements of the substances which are having solid state, more strength, more density, high melting points and boiling point, malleable, ductile, sonorous, luster, allow the heat and electricity. So those elements are having all these properties, we can call as metals. Those materials or the elements did not have these physical properties like say solid or liquid or gas, density, melting point, boiling point, malleability, ductility, sonority, luster, heat and electrical conductivity. The element did not have these physical properties are considered as the non-metals. But each the physical properties having exceptions. So we cannot classify the elements as metals and non-metals. We cannot classify the elements as metals and non-metals as based on the physical properties. Okay. So thank you for this session.